of the coast, including the territories of the Musqueam, Squamish, and the Salaway Creek Nations. We stand in solidarity with all communities marginalized due to race, ethnicity, sexual orientation, or age, and commit ourselves to opposing racism in all its forms. For those who are not on our mailing list, we encourage you to go to our website, www.nwcf.ca, click on the blue button, and you can at the top of the page, and you can join, take a form, and you can sign up to receive our emails about upcoming events. And speaking of upcoming events, on February 25, 1 o'clock, another Zoom, the Northwest Surroundings Foundation will be hosting a talk with Neil Forrest on engineering solutions, ornament to installations. Later in the spring, Kate Metton and Kathy Tarapoki, both recipients of the BC Achievement Award for Applied Art and Design, will present a panel discussion monitored by Dr. Carol Mayer about the challenges of working with design, creating prototypes, and promotion through social media. And finally, the Northwest Surroundings Foundation would like to congratulate board member Carol Mayer, and she was the Northwest Surroundings Foundation founder, for having been shortlisted for the prestigious 2023 Robert Jekyll Award, presented by the Canadian Crafts Federation, for her extraordinary contributions to craft in Canada. She joins Amy Bogarty, another one of our board members, who was shortlisted in 2022 for this honor. We would like to extend our congratulations to Gilles Latour of the Canadian Society of the Decorative Arts, who was this year's recipient. And now to today's talk: robots and the human hand, from automation to improvisation in digital fabrication. Bryan, Cera, and Tom Lauerman will present their work and engage in a conversation with our board member and moderator, Jen Woodin. Bryan Cera is an artist, designer, and maker from Milwaukee, Wisconsin, currently serving as Assistant Professor of Object Making and Emergent Technologies at the Alberta University of Arts in Calgary. Bryan holds a bachelor's degree in interdisciplinary arts and a master's of arts and a master's of fine arts in art and technology from the University of Wisconsin. His practice explores the intimate and often dysfunctional relationships between humans and their technologies. He has shown work across the US and internationally in Australia, Canada, China, Great Britain, and Switzerland. In 2016, he founded the Think Tank, a digital fabrication laboratory dedicated to exploring the integration of emerging technologies into more traditional craft practices. Tom Lauerman earned his BFA from SMU Meadows School of Art in Dallas and his MFA from the Cranbrook Academy of Art. He is currently an associate professor, MFA graduate coordinator, and MFA graduate coordinator at the Penn State University. He's working within the overlap of sculpture, craft, coding, and design. He explores the emotional capacities of constructed space as a visual, tactile, and visceral experience. He's designed and built a number of custom 3D clay printers. He's created hybrid digital physical works via claymation, illustration, and interactive 3D models. He has exhibited his work widely in Berlin, Detroit, Philadelphia, Chicago, and elsewhere. Jen Woodin is one of our board members, is an artist, educator, mediation mentor, and beekeeping enthusiast whose creative process weaves together the craft of compassion, transformative social practices, ceramic object making, relation building, and contemplative technologies. Jen is currently teaching at the Kwantlen Polytech University, as well as Emily Carr University here in Vancouver. And she serves on the board of the Native Bee Society and on the Northwest Surroundings Foundation board. So away you go.
Thanks so much, Deb. And hello and welcome to Tom and Bryan. I'm so glad you're here with all of us today. As Deb said, we're going to start off with each of you presenting for us today, and then the three of us can have a discussion about all the topics we are going to cover, and then we'll open it up a little bit for Q&A at the end. and that'll be our flow. We're going to start with Tom today, presenting. And just before Tom jumps in, if everybody wants to turn off their video just to keep the tech running a little more smoothly, we will let Tom take over the screen here and begin.
Okay, thanks so much. Let me get started here. Okay, so I guess first of all, can folks see my screen okay? Yeah.
Looks good.
Okay, thanks, Jen. So thanks so much to the Northwest Ceramics Foundation for the invitation, and thank you, Jen, for moderating and for sort of putting this together. It's a great opportunity to talk about the way that we work and hopefully start a conversation about that. So a little bit about me. I've worked with ceramics for a long time, but I initially studied drawing and painting, and then I got interested in ceramics. And always I've been interested in technology and specifically digital fabrication as we've gone along. So on the left is an object that's kind of indicative of what I make now. This is a small sculpture that I recently finished. And people don't believe me sometimes when I say that the things are small and they're photographed like this with a kind of no scale reference in them. So just as a means of reference, like this is that object in my hand, right? So not particularly large. And I'll talk a little bit about why I enjoy small scale work as we go along. But I often, when presenting work, start at the very beginning and want to feel compelled to talk about like early works and early education and things that influenced you along the way. It was really fun to put this together because I started to think about a really different framework. And I decided to take as a starting point the spring of 2020, which I think we all remember as the beginning of the COVID-19 pandemic. The reason I chose that date is because I feel like as I was putting this together and looking at the work, I feel like something really significant changed in my own work at that time, and probably, in the ways that all of our lives changed at that time. So one of the things so I won't talk a lot about the past, but just know that I studied painting for a while. I've worked with ceramics for, 20 plus years, pretty familiar with all the different techniques. And then really in the last 15 years or so have increasingly focused on what we would call digital fabrication. And one of the things that I'm most interested in is 3D printing in clay. I've been interested in 3D printing itself for a long time. The first time I printed something was 2008. Then I started building plastic printers in 2013 and started building clay printers in 2015. So along the way, have met a bunch of really interesting artists and designers, including my friend Jonathan Keep in England, Dries Verbruggen in Belgium, and of course, Bryan Cera here today with us. The printer that you see here is something that I designed and built as COVID was going on, and this is one of the printers that I use a lot in my own home studio. But these are the types of things that I make. My work is really influenced by the experience of architecture, and I really like to simplify things down to kind of archetypes, arches, staircases, apertures, screens, walls, all these kind of basic building blocks of architecture seem to be themes that I come back to all the time. I'm really interested in surface and texture. I'm really interested in detail. And I really like, having a contrast between sort of like crisp, hard edges and sort of slightly looser textures and techniques. So technically, I wanted to show the process of the printing, the way that this 3D printer works. So this is the printer that was pictured a moment ago. And so you can see that there is a ceramic tile that this object is being printed on, and it moves to the left and right, the x-axis, and it moves front and back. That would be the y-axis. And I have a couple views of this process. And one of the things that's really cool about building your own machine is that you can just build it to your own specifications for your own needs. And so if I were to start trying to work with clay printing now, I would almost certainly start with a commercial device that's out there, because there's some really good tools that are available now for manufacturers. But in 2014, 2015, I didn't feel like there were particularly good options. And it became this really intense experience of taking several years to design and build and iterate and refine the idea of a 3D printer that would work for my work. And so the thing that's maybe a little bit different about what I try and do is that the layer heights are very small. The extrusion here is really small. You could think of this as coil building, but each coil is like 1 millimeter or slightly less than 1 millimeter in diameter. But in practice, it's really just coil building, just like we all do in a beginning ceramics class. So in contrast to commercial machines, I guess I would say that what I do takes much longer and ends up being much smaller. So those are not necessarily great selling points, but they're the points that are really important for my work and what I want to do with this process. So here are the types of objects that I make. These days, everything that I make begins in a digital space. I begin by making a 3D model. Sometimes that 3D model is based on a hand sketch, but nonetheless, it starts as a model. It's usually printed, and then it's usually hand worked after that. And then there's a whole process of firing and glazing. And the clay that I'm using is kind of like ordinary clay that we use in the studio at school. So this is a really sped up video, but I think it shows my typical process really well. I print a number of components. I really love modular things. And then from there, I can start to hand work things. And I really like to play around with surface textures. And I start to sort of hand build, almost like I've got these building blocks or, bricks. I'm sort of putting them together in a way that's very familiar to anybody who's been doing hand building for any length of time. Function and utility does not enter into my work for whatever reason. I've never tried to force that, and it's never come to the forefront. So I consider, the work that I do in clay sculptural work, and that's the way it's always been. And prior to that, I was doing painting. So I do not engage with the vessel tradition much. I have this idea that for me, the basic element that you could reduce ceramics down to is like a brick rather than a pot, right? So if you took that frame of mind, you would then move into like modularity and brick building and architecture and things like that, rather than utility and food and durability and things like that. So the range of objects that I make, I hope, demonstrates that if something is involving 3D printing, it doesn't have to look a certain kind of way. You can really work with all kinds of textures through this process. And in part, that's because I'm very comfortable taking the things that are printed and working them by hand in the ways that I think we're all familiar with. So the reason I talked about the pandemic was prior to 2020, I had for years and years done tons of digital work, and all that digital work was behind the scenes, right? So it's making models for things, preparing for 3D prints, just doing all this design work that I never shared with anybody. What I shared with everybody was the finished ceramic object. They didn't have to know much about what came before that. Like a lot of artists, when the pandemic started, I had to cancel some shows, and I had this realization once I got over like just the enormity of like dealing with the pandemic, as we all did, that nobody was going to see the physical work that I was going to be making for kind of a while. And so it was an interesting time to maybe really dive into the digital work that was there. And I did, I think, consciously think a little bit like, well, maybe I can make some things that express these forms in a way that people can relate to if they're not seeing them in person. And so I kind of started mining the digital work that I had been doing. I also began just teaching myself more techniques in that realm. So this is a piece called Surface 01. It's a GIF image. It was made in Blender, which is a 3D modeling program I'll mention a few times. And the idea here was I had just made a really heavily textured surface. And then I had drawn over that, like line by line with the stylus. So it's sort of hand drawn in a digital space, and then animated that to just rotate around. Super simple. But I guess I mentioned that because I wanted to think about this idea of sort of, presenting the digital work that was going on. For years, I've worked with a device called a pen plotter. I think Bryan also works with pen plotters. And in conversations with a graduate student of ours, Audrey was using a pen plotter to make some tiles, which was a really wonderful way to think about it. So instead of dragging a pen across paper, it was carving into clay. And I had mentioned to her how clever I thought that was, but also that I was working with these animations. And I thought, would you mind if I borrowed this idea of using a needle tool to make a animation frame by frame? And we talked about that a little bit. So this was the first piece I made in that way. And so it's an animation of a sort of two-tiered arch spinning around. And what's happening here is each frame, and I think there's 123 frames here, is drawn by a pen plotter and photographed. And then this is on a wet piece of clay, and it's just simply like smeared smooth in between each frame. And I was just really struck with this when it sort of wrapped up. And for me, it feels like a little bit of a window into my mind and the way that I like to think about objects, think about form, try and like close my eyes and rotate things around in my mind. I just had a connection with this that was surprising. And I wanted to talk a little bit about process for some of these things. So here's how I work. On the left, I designed this piece that references stairs. A lot of my work talks about stairs and basic architectural elements. But on the left, it's a digital model that was made in Blender. Again, that's a free open source 3D modeling program. And it has this kind of texture applied to it through a process called a displacement modifier. So I feel like the texture looks kind of canny and kind of like synthetic on the left. And then when it was printed in wet clay over here on the right, it starts to be kind of more realistic. And I like the way that the texture was mediated by the printer. And then glazing the piece and finishing it, you know, I was really happy with the way this looks. And so I guess there's always that moment where you feel like maybe this isn't finished. Maybe I want to keep doing things. And I like the idea that maybe, you know, we never really finish work. We just bring that work back in a different form. So I wanted to do something with this, and I didn't know what. And the first thing I did, which was maybe a little strange, was to make a 3D model of it from a scan. So using a whole bunch of photographs and a process called photogrammetry, I remade the 3D model from the actual physical object. And what was funny about that to me was that like suddenly the surfaces are much more convincing because it's not a synthetic thing. It's like a, I mean, I guess it is, but it began as a physical object and now I'm bringing it back into the computer. But I didn't know what to do with that. And I was playing around with animation. And again, in Blender, there's a wonderful feature that allows you to just draw and select what surface you want to draw on. So I brought the model in, I hid the visibility of the model, but I could still use it as a surface to draw on. So I made this animation where every frame I'm just adding a little bit more to the drawing, like 2 or 3 stairs and a staircase are added for every frame of the drawing. And this is what it looks like within the program. And I started playing around with things like, you can see the little orange camera moving up and down in the back. So I have to like try and learn a little bit about, you know, how people do animation. I'm not trained as an animator by any stretch. So this is what that looks from the camera's viewpoint, how it looks from the camera. And I was really pleased with this, just really simple. I always try and bring things back to a pretty simple elemental basis, but still really craving to like connect this up with clay in the way that I work. So this was sort of the final version of this animation, Stairs 01. And so I had this idea of calling this sort of like a claymation palimpsest. That's a mouthful, but the idea that it's claymation and that it's frame by frame and it's photographs, but it's also drawn and written over, you know, it's like a piece of paper that's just been inscribed upon, in this case, 174 times. And it picks up a lot of residue from the previous frames and things like that. I wanted to do a similar piece, but using the 3D printer, the clay 3D printer. So this is just a really simple cube. I love to bring things back to something reductive. In this case, when you turn on Blender, it presents you with a default cube. So I didn't even model this. I just took the default cube and rotated it, but found a way to basically make, in this case, 58 3D prints in which each print is just a little outline of the cube as it goes around. Then this piece, Dwelling 01, based on a sculpture that I had made, and then really playing around with like white and black clay slip just to see like how atmospheric can this get, how complex can this get as a landscape as we go around. I also became really enamored with this idea of a digital twin. That's used a lot, that terminology, in like sort of architecture and engineering for like if you have a modern building that has all kinds of control systems that are real time, they call that like, you know, you would build a digital twin of the building so that you could monitor it in real time. I'm not interested in that so much, but I'm interested in the idea that a physical object that you make can have a twin digitally that has sort of all the, as much information as possible that the original has. And so also during the pandemic, it was really interesting, this idea that like I could make online in a website, I could have this you know, 3D model that's accessible by somebody. They can rotate around and zoom in, zoom out, feel almost like they're holding this thing, and certainly can look at it up close more so than you could a physical object. So there's a few of these. It's all made through photogrammetry, meaning that I take many, many photographs of the object and then in software bring those all together to make a 3D model. And I really love how it messes with the scale. This is a tiny, tiny object, but I like the monumentality that it has in this kind of virtual mode. So again, I'm not trained as an animator, so some of my animations are pretty clunky. I was trying to teach myself what's called shape keys in Blender, which are just ways to move objects in this way, this kind of like sliding, graceful movement from one position to another. So I had this really simple animation, 12 cubes that just do different things. But I'm not, this doesn't do it for me. It's just this little digital clunky thing. But I wanted to bring that to the, like 3D print that, where each frame would be a different 3D print. And so it's easier to do that in plastic than clay. So I made this project 145 objects. And so it's that same animation we just saw, but for me, it's just wildly different as a physical materialized thing. So this involved 3D printing in plastic, 145 different little objects. This was a nice way to use up a lot of extra colors and things. And so I kind of like the way these weird haphazard textures would come in from various faults and issues with the printing process. Again, simple things. I was trying to teach myself and then later my students how to use what are called geometry nodes in Blender. So it's just a little way of taking this cube and causing it to bounce sort of back and forth. Really simple little demo that I was following. And I just was kind of tickled by the idea of 3D printing every frame of that, and that when the cube is tilted, because of the nature of 3D printing, it would need support material underneath it. And so I wanted to visualize that. And so I made this animation, which is actually quite difficult for me to make, but it shows what this would look like as 3D printed objects. And then I thought, I really wanted to make one of these animations, but have it be printed out of clay, and that this would be a good starting point for that. So this was the result of that stumbling block from last year, 2023. And so this is, again, 31 frames of this cube kind of bouncing back and forth. And I just was really pleased with the way that this worked out. And in a way, there's a lot I could say about this, but sort of a celebration of terracotta, which is a material I really love. But also this idea of this thing, like, is it falling? Is it being caught? Is it jumping? Is there something wrong here? The print quality is a little sketchy because the object's so small. I don't know. I could talk about this piece a lot. I'm really happy with it, and I'll move along. So came back to the idea of this pen plotted surface, and this is the exact same animation I showed before. But again, like just that hunger to make it material. Like, could I revisit that in clay? And I also liked the idea of kind of pulling the camera back ever so slightly so that you could see this is a tile on a table. It's maybe like 4 by 4 inches, something like that. And that there's a little bit of like, just crumbs that get everywhere and slip that spills out everywhere. So the process here again is to paint on white slip, have the pen plotter draw all these lines, and then smear all that, paint the white slip on again, and keep going. So this one was 100 frames. And I have these sort of videos that show some of that process. So for 2 different pieces, you can kind of see the pen plotter moving this scribing tool. And then there's a lot of like painting and just smearing of things that happens. And so you do all this work, and sometimes the pen plot itself might take, 15, 20 minutes to do all those lines. And then you get one frame of the animation, and then you go and, prepare the clay again, do that again. It's a really labor intensive process for something that ends up being, between 3 and 10 seconds when it's all done. But I do find this process really engaging and kind of gratifying. The most recent work I have here is called Test Tile 01, and this is ongoing. I want to make a second version of this where this is obviously unfired clay, but I fired all of these, and I like the idea that each one would have a different glaze on them. They would sort of cycle through a chromatic rainbow as they go along. But the idea being, I love test tiles so much. I won't talk about glaze today, but I do lots of glazing, and I teach glaze formulation. And I also love the low stakes idea of a test tile, like something that you haven't got all your hopes pinned to, but nonetheless represents a lot of optimism and possibility. The idea of a test tile. I like the idea of sort of having a test tile mindset in the studio. The idea that like, if everything you could conceive of as a test tile, then perhaps you could be a little less hard on yourself about being a perfectionist or taking too long or not taking long enough with something, but just saying like, hey, it's a test tile, even though it took me 4 days to make this test tile, it's a test tile. I also enjoyed in this one, like 4 or 5 frames of this got like completely mangled. I dropped the container that they were in, and I had to rebuild them by hand. I didn't have to, but I decided to. And so there's occasionally one that sneaks in here that's basically handmade in the middle of these sort of 3D printed ones. So I'm enjoying that variation. The last thing I'll mention here, and I'll wrap up, is I've been thinking a lot about how to present things. So on the left is an object that I made, and on the right is an animation. So I like this idea of perhaps pairing the animation with the object. The animation is running on a Raspberry Pi computer with a very small screen. So that's one way I've thought of doing this. Cube 01 and the second cube 02, I had this idea of making a diptych, and this was for a pop-up exhibition at NCECA, and we didn't know if we would have any access to any power outlet or anything like that. So I had a lot of fun building this little, it's a battery pack at the bottom, and then this little 3D printed rig that holds these 2 little computers and these two little screens, and it can run for an hour or so. And so I like this idea of like, I make small work, I'll have these small little devices that run that small work. But I was tripped up a little bit in a very pleasant way. I wanted to thank some artists I met in the digital space, Uberneath and Strano, for including my work in an event in Montreal, Tez Art Montreal recently. And they were projecting the work of all kinds of digital artists on a large scale. And I was not able to be there in person, so I haven't projected my own work at this scale, but it was wonderful to see. And it's wonderful how sometimes somebody kind of prods you along without it like wouldn't have occurred to me to make these so large, especially since the objects that are being depicted are incredibly tiny. But the photographs that make up these stop motions are very high resolution. And so there's a lot there. And there's also a funny irony that I've spent so much time trying to make a 3D printer that can do really fine detail, only to project that like many, many times larger than life size, so that all of its flaws just come like right to the surface. So this is where I'm going to leave off. I make these physical objects that are small in size, but I like to think sort of large in scale. And thinking about these a little bit larger, a little bit more immersive is interesting. I always feel like small scale work in its own way is kind of installation-like or immersive in the sense that you can kind of project yourself into it mentally. So it's interesting to think about that, on a larger scale as well. So I hope that provides some insight into these ways of working and might be of interest to the audience. So thank you again, everybody.
Thanks so much, Tom. That was amazing to see. I really appreciate getting a bigger sense of what you've been playing with in the last couple of years even, and where it's going, and actually just how you're thinking about your process in general, where you're going with it. So appreciate that. And we're going to go ahead and see if Bryan's ready to queue up for his talk, and then we'll get together and talk about this in more detail, what you presented there. I made some fun notes with that. Thanks, Tom.
Hello. Is my microphone working?
Sounds great.
Great. Give me just a sec here. Oh. Try this optimize for video clip thing. Okay.
Looks good.
Oh, there we go. All right. I just want to say before I dive in here, thanks to Tom and Jen for meeting up a couple times to kind of arrange this whole thing. The talks were fun and inspiring, and Tom, your presentation was really great, and you just continued to inspire me, and I'm sure I'm not alone there. So thanks a lot. Yeah, so I'm excited to be here, and unlike Tom, I am gonna dig up my past a little bit, but that's partially just because I think it for 2 reasons. One is that we're all maybe more familiar with someone who is a ceramist and found their way into digital fabrication, and in Tom's case is really become a new media artist, where I'm kind of the opposite. I really started as a new media artist. I was making interactive interactive screen-based work. And then I ended up finding this strange trajectory into clay and ceramics, where I've been willingly stuck for the last 6-7 years. But I also want to kind of go way back, actually, to when I was 12 years old, because I've realized lately that my practice has kind of come full circle. So I really became interested in making art, designing things, and just making things in general through the process of discovery. And a lot of that happened when I was around 11, 12 years old and got my first computer. And so I'm going to start with an animation that I made in Microsoft Paint called Stinky Stinkerson. And this is, again, I made this when I was 12. Yeah, that's how a lot of my animations ended when I was that age. I was fascinated with just the characters getting mangled horribly at the end. I don't know why. But this was like one of many, many animations that I made, and I made them kind of painstakingly, one frame at a time, again, using Microsoft Paint. I made the music for this too. I was just really interested in, I guess, the accessibility that the computer opened up in terms of making things. I realized I could make cartoons, I can create digital drawings, I can make music. And whoop, we don't need to see that again. Later on, that turned into an interest in coding. So even though I did really poorly in my math and science classes in grade school, later on in life, I started having this strange to me interest in math and science. And it really was because I realized I could use them to make things. So I started learning how to code so that I could take my ideas for animation and actually make them interactive. This is just a little example of a little alien octopus creature, and you can feed him little treats. And around this time, I started kind of becoming aware of other creative coders in the world and looking at some artists, some new media artists. And one of my favorites was Gohan Levin, who makes interactive work. And he describes the mouse and keyboard being kind of the narrowest possible straw that you can suck all of human interaction through. And so I became interested, inspired by him and some other new media artists, to start exploring other ways of interacting. So I made works like this. So this is called Pong, and it's based on the classic arcade game Pong, actually technically the first video game ever. But here, instead of moving the paddles with a little controller or a joystick, you do so by screaming into a microphone. And this actually was I kind of stumbled onto by accident. I was actually testing the microphone input just before I really had anything to make with it, before I had made any interactive animation. I was just wanted to test the microphone, and I had already made years earlier as an exercise Pong in a programming environment called processing. And so I just hooked the microphone up to test it, and I realized that this could be an amazing work for a gallery. It would force gallery participants to walk into this like pristine special space and scream and kind of make a spectacle of themselves. So using audio as an input instead of mouse and keyboard kind of led to, well, around this time, this is around 2010, there was this thing called an Xbox Connect, or a Connect sensor. And it was a device made for video games to allow you to use your body to play video games. And around 2010, someone hacked it and kind of opened up all of the code inside. And so that allowed artists like myself to start to explore using that to make art. This is just an example of what the Connect can do, a basic example. I apologize about the music. But basically it creates a point cloud. It uses some structured light scanning technology to make a live point cloud of your body. And so the first thing that I wanted to do was to try to, kind of how I had used Pong as an access point, the recognizable environment of Pong. I recreated an environment that I grew up in, Super Mario World, and set up an installation where participants could use their own silhouette of their body to interact with the familiar space. And the really fun thing about this is that you don't actually see Mario here, but everyone is familiar with that, even the universe that he's lives in, and familiar with the rules. And you can step on the turtles and kick them, and you have to watch out for the enemies. So that was me kind of exploring my interest of traversing a digital space with your physical body. Shortly after that, I created this robot that allowed me to do the opposite, traverse a physical space with a virtual body. And these actually, I found out shortly after building this, that there are commercially available things like this called telepresence robots that you could use to commute to work long distance or something like that. But I'm actually just showing this because this was one of the first objects like that required me to learn a lot about how to build objects, really. One of the first big objects that I made. And I realized that I did have an interest in using my hands in building physical things, not just moving pixels around on a screen. And around this time, because I was really thinking a lot of not just about how to celebrate technology, but also how to be critical of it and how to, really just thinking about how technology changes and alters us socially and psychologically. I was reading this book by Sherry Turkle, and in it, she coins this phrase, the phantom ring, which is the phenomenon that a lot of people have reported experiencing, especially young kids with cell phones, where they feel their phone vibrating in their pocket throughout the day, even when they don't have their phone on them. And so I thought that it would be an interesting challenge to try to literalize that phrase, the phantom ring. And I came up with this. This also was I feel like whenever someone is learning a technology, like a creative technology, there's always that one project that kind of forces you to really dive in deep. And for me, this was that project for computer-aided design and 3D modeling. So this is glove one. And the idea here is that you replace the functionality of your hand with the functionality of a cell phone. And so I created a
Hello, everyone.
functional prototype.
I'm from your telephone company.
It's called Glove One, and it's a working cell phone that you wear on your hand and you talk into it like Inspector Gadget. And the distal, middle, and proximal segments of each finger become keys for the keypad. And I guess just a quick funny note about this, that I posted this same video on YouTube without much of a description, and people mistook it as a Kickstarter. And I got tons of feedback, which was awesome. Half of it were people saying, I need this glove phone. And then the other half were saying, this is absolutely useless. And that second half, I think, hit the nail on the head. That's what I was going for, to kind of like confuse utility with futility and explore that dysfunctional relationship with technology. That led me into another project where I kind of wanted another crack at building a robot, because the first one I made was, let's just say, it involved a lot of hot glue and last second duct tape and things like that. So knowing how to 3D model, and also having worked with the company that would print models for me, I didn't own a 3D printer at this time, I decided to build another robot that I had in my mind. And really, this robot, to keep it short and sweet, the idea was that it was an industrial style utilitarian machine that was designed specifically to procrastinate. So I programmed it to do things like traverse or walk back and forth on this 20-foot track I built. And I made it neurotically check the refrigerator. And I loved people coming in and just expecting this to do some important thing, but it kind of just wastes time. And of course, I had to make it look at pictures of cats on the internet. So yeah, and I think really here, I was just thinking about the fact that robots are performance machines. In a lot of ways, humans kind of measure themselves to them. I mean, you've heard someone use the expression, oh, he's so good at that, he's like a machine. So I thought it would be interesting to build something that you wouldn't want to compare yourself to, that this robot that actually acts more like a human by not working, by not performing. Then I built probably one of the more pivotal robots in my life. So in around 2008, Adrian Boyer was a researcher in Bath in the UK, and he started this project called RepRap. The idea was a 3D printable 3D printer. And so in 2009 is when I caught wind of this, and I used a 3D printer at my university, a commercial 3D printer, to print the parts for this machine and the plans for this machine. This machine is not my design. It's called Mendel Max, and it's kind of a framework for what at the time was a really popular framework for DIY 3D printers. And so, yeah, I built this around 2009 and started really doing a lot of projects based around the idea of 3D printing and rapid prototyping. And one of my favorite ones is was a collaboration with my friend Scott Kildall, and it was based on this archival photograph of Marcel Duchamp's personal chess set. This wasn't one of his works of art. This was actually a chess set that he made when he was, I found out later through lots of research, studying with some carpenters in Buenos Aires, Argentina. And he made this chess set, not as an artwork, but just because he was a chess player and wanted a handmade chess set of his own. But this was the only photograph that existed of this set. And Scott and I were really fascinated. We're both really interested in chess. We both really love Marcel Duchamp. And so we were interested in doing something with this project. So since I had some know-how with 3D printing and 3D modeling, I took that photograph and I basically just extracted geometry directly from it and a little research about the set itself and its dimensions and things like that. And I recreated this chess set, kind of just modeling it by hand. I didn't have any access to the set itself. In fact, the set at the time was, the set at the time was thought to be lost by most people who had read about it. So I just created them based on what I thought this photograph was. And then I took those 3D models and I shared them on this thing on the internet called Thingiverse. And at the time, Thingiverse was new. And essentially it was like YouTube, but instead of for watching and sharing videos, it was for downloading and uploading 3D models. So you could share a 3D model for people to download. You could download their models. And it actually ended up being really successful because, whoops, that was a spoiler. It ended up being a really successful project because hundreds of people downloaded this, 3D printed it on their own machine, and then even sent photographs of their 3D printed set. So it was going really well. I considered this project a success. And at the time, it was called Ready Make Duchamp Chess Set. And it was a play on the ready made. When you make something on Thingiverse that someone else designed, you can upload it and label it as a make of their design. So this was the Ready Make. Maybe a year went by and I had kind of forgotten about this project when I got something crazy in the mail. It was a cease and desist letter from the Duchamp estate. And Duchamp's heirs were basically claiming intellectual property infringement on my part by creating this set. Now I really meant this as a way to celebrate Duchamp. I thought it was a way to kind of like, I guess, celebrate Duchamp's success at recontextualizing existing objects with his ready-mades. And I thought I would recontextualize his object. Did not at all mean it as, a diss or to try to profit off of Duchamp or anything like that. So I contacted the Duchamp estate directly and basically said, I will take it down from the internet. I apologize, scrubbed it as good as I could. But the thing is that by French intellectual property law, I probably had infringed. But by US copyright law, where I made the work, it becomes public domain 60 years after the publication of the work, where in France it's 60 years after the death of the author. So there was sort of a conflict there because I hadn't made the work in France, nor had Marcel Duchamp made his work and published it in France. It was published in a book in Buenos Aires. So I didn't really think there was legal grounds to sue me, but at the same time, I did not have the teeth aka money, to fight. So I scrubbed it from the internet, and I went back with Scott to the drawing board, and we really thought about, we really loved this project, but we didn't want to. We want to be able to go to France one day without going to prison, basically. So we thought about it, and we took some inspiration from Marcel Duchamp himself, from his Mona Lisa with mustache, and we re-released the chess set into the public domain with mustaches. So it's now called Chess with Mustaches. And the cool thing about French law is that while they have really strict intellectual property law to protect intellectual property, they also have really strict laws, and some of the first strict laws in the world, to protect parody artists. And so these mustaches really mark these objects as parody. And honestly, I think they look better. I mean, these guys look great rocking these stashes. So, okay, so in addition to starting to explore 3D printing and object making, I was still very much loving creative coding. And I realized that a lot of my explorations in creative coding were really explorations in geometry and kind of just falling in love with the subjects in high school that I failed. So, and as my explorations in creative coding became more dimensional, I started really being interested in, can I code to create objects in the real world? And I started learning this program called Grasshopper, which is just a visual programming environment specifically for making 3D models and 2D models. And the first thing I started doing with this was using Grasshopper to program drawing robots that I had built. So this is a kind of cool robot where you can actually, it has little laser registrators that I built in, so you can re-register it and continue drawing outside of the frame of the robot. This is me drawing I almost said rhinoceros. This is me drawing a triceratops at a Maker Faire event using that robot. And then, I had mentioned that a lot of these explorations just come out of like curiosity and desire to discover. And so I thought, what would a drawing robot or a plotter look like if it didn't have a frame at all, if it was free to roam around? So this was a little rover drawing machine that I came up with and did some experimenting on. But I really wanted to use Grasshopper ultimately to make 3D structures in the real world, not just drawings. And the problem that I really ran into immediately was, if I'm doing experimental 3D printing, I'm going to generate heaps and heaps of plastic garbage. And I just wasn't comfortable with that idea, especially because most of the things I was creating didn't need to be permanent. And plastic is a very permanent material. Even the bioplastics that a lot of people talk about printing with, polylactic acid, still lasts thousands and thousands of years if you don't hit it with intense energy like ultraviolet light. And so, yeah, we're generating a lot of plastic garbage when we're purely experimenting in 3D printing. And that's when I started searching for a material that was truly recyclable, that could be used over and over again. And I became aware at that point of Tom Lauerman at Penn State and Keith Simpson at Alfred. And they had built their own 3D printers. And I knew by this point, there were commercially available 3D printers. But again, I am so inspired by that process of discovery that I decided to just try building one. It seemed simple enough at the time. It was like, squeeze some clay through a tube and use a robot to move the tube around. I didn't know what I was getting myself into, but the problem is that Tom and Keith made this look really easy. But this is my first attempt at clay 3D printing. And instead of a robot, I asked my colleague Zimmer Biner to move that tube around as I squeezed clay through it. This was really just me wrapping my head around things. And to me, oh, this is going to work, even though this clay ended up being not at all the right clay to use for many reasons. Regardless, I strapped this thing to a robot. This is a Delta 3D printer. And it basically just uses trigonometry to locate the end effector, the tool of the machine at any given point. This is my first 3D print with this kind of improvised setup, and that's how most of my prints ended up at that time, flopping over. So dramatic. But eventually I started to figure things out, started learning more about clay and what it needed to be to stand up, and you know, how wet could I make the clay, and does it always make the clay more rheotropic to add water to it? Not necessarily. Some clays don't have an affinity for water. So the actual, you know, the composition of the clay body itself really mattered. And exploring those things and glaze made me fall in love with clay. So this was supposed to just be a little experiment over the course of a few months, and I ended up diving in deep and sitting in on ceramics courses taught by my colleagues, and spending a whole summer learning how to hand build just so I could understand clay better. And then I ended up building a purpose-built, more intentional clay 3D printer. And this is one of the first prints that I made on it. And it's actually similar to what you saw Tom working with earlier. You can see that the bed of the 3D printer is moving while the extruder, the part that's pooping the clay out, is stationary. I ended up changing that in a later design. And so this was my most recent 3D printer, clay 3D printer design. And it has a unique characteristic of the only thing that moves is the extruder. It moves in X, Y, and Z axes. And so the object itself sits still, which didn't seem important at first. It just ended up being how I built this one. It just made sense to me. It was actually inspired by a design of Keith Simpson's printer. And I designed some special electronics that gave me precise control over the flow and pressure in the clay extrusion system. And this was exciting for me because it was one of my first professionally fabricated circuit boards that I designed, and you know, felt just like, wow, I guess I felt a little bit like Tony Stark in Iron Man. I was like, I built this thing and it's so shiny and techy. Though I don't even use this anymore, but I wanted to throw that in there. What I ended up doing with that clay extrusion system is publishing it as an open source project. And this was actually really inspired by all of the makers that I had learned from over the years on the internet. I think just the coolest, so out there on the internet, you can find plans, bill of materials, 3D models, videos demonstrating how to assemble all of the parts, etc. And I think the most exciting thing that happened with this is that I saw people starting to build this thing and, you know, emailing me questions. And I set up a little message board because I don't have time to do free technical support. So I set up a message board so that people could create their own community and learn from each other. And then lo and behold, I saw at first, Keith Simpson printed the parts for my extruder. I didn't see this coming. I was so excited. And then even Tom Lauerman reached out to me, you know, saying, hey, I'm trying out a few of the parts, the components from your printer in one of my machines. And it's just so flattering. It really felt like, you know, if I was a basketball fan and an NBA player called me up and asked if I wanted to shoot hoops. That's how I felt. It was just beyond flattering. And then in the corner here is a really interesting project. And I wanted to include this just because it might come up in the Q&A or in the panel discussion later, so I could throw this slide on again. But this is Osberta Kapunaman, probably mangling his name. But he was a Carnegie Mellon master's in architecture candidate and ended up using my open source extruder, strapping it to a robotic arm for his project. And his project is really interesting because it's kind of this call and response between the human hand and robot. And I think we'll talk about this later. So I'm just gonna remember this slide in case it comes up later. But this is essentially the 3D printer prints, or the robot prints a part of the design. Then a human changes it, alters it by hand. And then the robot responds by extrapolating what the human modified and automatically, presumably, building the next part. Around this time, I was really interested in the idea of the machine or the tool having agency in the part. And something that I thought about was atmospheric firing. And I know for a fact, actually, this was at North Mount Pleasant Ceramic Center in Calgary. And this was, I saw in the audience today is Robin DuPont, and this was, he actually assisted with this firing, which was really cool to see. And I learned so much. And he might argue with me on this point, but I think that, you know, when you think about atmospheric firing, you can make some decisions of what's going to happen to your piece when you put it in. But at the same time, you are leaving some things up to chance. What is the surface finish going to be like? You don't know exactly what the flashing and things are going to be like. And so it is this marriage, this happy marriage of decisions that I've made as a maker and the agency of the tool itself. What is it going to do? It's going to surprise me in a lot of ways. And so that idea inspired a series where I actually wrote an algorithm in Grasshopper to generate a vessel, and that I would only see the vessel when the 3D printer printed it. It actually only existed as a tool path, not as a 3D model at any point. And then, of course, I atmospheric fired those as another call and response, kind of taking this object that was created as a collaboration with a robot and then finished with the collaboration between myself and an ancient technology, the kiln. So back to that printer that I designed, where the object stays put. The printer moves, but the object stays put. One thing that I realized after I made this time lapse is that because that object stays still, you have a good frame of reference, and it actually appears to be moving. Especially if you watch just the tops of these little towers that are being built, they appear almost as 4 circles that are separating and then converging. And so I'm a huge fan of Edward Muybridge, you know, often credited as inventor of the motion picture, but best known for an early animated photograph series of a horse galloping. Well, he actually has thousands of series of animal and human gaits. So animals running, walking, humans running, walking, etc. And they're all in the public domain. So I took one of house cat running, and I broke it into a bunch of vector frames, so scalable frames. And then in Rhinoceros, which is a 3D modeling software, I interpolated between those frames. And so this is actually a stop motion. This is not nearly as much work as what Tom has made, though, because my printer is printing. And then I also built a little camera rig to move the camera as it recorded a time lapse. So what you're seeing is a 3D print sped up, but it creates an animation. And this is what I'm talking about, coming full circle. This is where I began becoming interested in computers and art, making animations. And through this strange trajectory, I'm still making animations. I love that Tom and I both ended up doing this by completely different trajectories. And it's just really kind of blowing my mind right now. So many of the things he was saying just resonated with me so much. And now I don't have to say them. But this is another one of these animations that I made. And this is Edward Muybridge's Nude Descending a Staircase, which of course inspired many futurists and Dada artists to create paintings and other works based on this specific photo set. Also interesting, there's stairs here. And it's just, Tom, I was not even thinking about your work when I made this. And it's just, yeah, uncanny. Around this time, I had a studio visit from a Calgary artist, Greg Pace, and Greg is known for doing these huge, well, they're not all huge, but for doing these vessels that when put together, the negative space creates the silhouette, usually of a human, but sometimes of animals. I had a studio visit with him and we were chatting, and it turns out he is a huge fan of Edward Muybridge and has done some work based on it. And he got really excited when I showed him my time-lapse clay animations. And I enjoyed seeing him get excited, seeing an artist that I respect a lot and whose work is very different from mine get excited about something I made. And so my brain kept coming back to his work, and I ended up reaching out to him and asked if he wanted to collaborate with me. And my idea was to take one of a similar structure where you've got 2 vessels creating the negative space for a figure or a form, but actually animate it animate it in the real world. And I had this idea in my mind how to do it. I had no idea how to actually accomplish it, but I just knew from the knowledge I did have that it was possible. And after some time, I figured out more or less how to make this happen in Grasshopper. And it's not that different from the time-lapse 3D prints I had been doing. But these would exist as static vessels that you could actually experience them in real time, not just through a video. And so this is the first prototype. And I thought that the simplest thing that I could show is just the human rotating. And so you can actually see that the silhouette, even though it doesn't, there's no human there, it is actually three-dimensional. It's three-dimensional in its negative space. This, of course, so this prototype I made by 3D printing in plastic and creating a slip cast mold, just to have a more, I guess, detail packed in there. And then that made me go down this whole rabbit hole of slip casting, creating 3D prints to slip cast. And the interesting thing is that this form that I created this slip cast mold from was created in Grasshopper, which is that visual programming environment. So what I decided to do with these forms is using a laser engraver, I actually etched the algorithm into the bottom of the vessel. So if you get your hands on this vessel, embedded inside of it is the code that birthed it. So if you actually plugged these exact components into Grasshopper and connected them this way, it would create this 3D model. This is when COVID happened, and I was just learning how to wheel throw. A little late to the game, I know, but I was learning to wheel throw, and I was falling in love with it, as one does. And this is like my first mug I ever made and my first jug I ever made. And then COVID happened, like literally the day after I shot this video, excited, look at me pouring my things I made on a potter's wheel. COVID happened, I lost access to everything for like a year. But I wanted to keep exploring it. So I grabbed some kind of components from old projects. Actually, most of these components are from the 2 robots I showed earlier. And I built my own little potter's wheel while on lockdown. This one I just control with a little knob. I ended up making a pedal for it so I could control the speed. And this is me in my basement during COVID. I didn't have any studio space. I'm really cramped little basement. And I'm throwing tiny little pots so I can keep exploring, I guess, the joy of these objects of excuse me. Sorry, so I could keep enjoying these, building these objects. The last thing that I want to show quickly, again, this is kind of an accident that happened through COVID, but I was really desperate to fire things because not only was I falling in love with clay, but I was falling in love with playing with fire, which is one of the, I think just, I love the idea of people gathering around a hot kiln in the cold weather. And I was just loving that. And that's when everything was interrupted. So I started kind of desperately searching for a way to get a kiln during COVID. And the best thing that I could find was this thing called a microwave kiln. And these are actually intended to use for glass artists, for people melting glass and creating beads and things like that. But I read that they could get really hot. And the idea is that there's this silicon carbide material on the inside of a refractory container. And silicon carbide, when it is exposed to microwaves, it starts absorbing them. It starts heating up, and the hotter it gets, the more microwaves it absorbs. So it's sort of this exponential heating happens. And it gets hot enough in your same microwave you use in your kitchen. It gets hot enough to melt stone, to melt metal, and yes, to fire ceramic. So I was firing these tiny pots that I either 3D printed or hand threw on my tiny wheel during COVID. And then I was firing them in my microwave. And because of the rapid heating and cooling, I researched clay bodies used in raku, which can usually withstand that rapid, more rapid firing, because I forgot to mention, it only takes about 6 minutes to fire a pot this way. And so because I was using raku clay and glaze, I decided to try little tiny raku. So this is me in my backyard during COVID doing tiny miniature raku from a microwave. And I ended up making this into a mini workshop as part of the longer workshop I gave at Madalta last summer. Okay, I'm gonna actually stop there. And I'm really excited to follow this up with a conversation with Jen and Tom. And I just want to say thanks everyone for joining me. And I guess last thing is that almost everything you saw in my presentation was just ripped off my Instagram. So if you're interested in more things like this, you can find me there.
Wow, thanks so much, Bryan. Super exciting to see the full range of what's happened since COVID, but even since you were 12. And it's really enjoyable all the way through. I love seeing your journey from a different area of interest into ceramics and where you could take ceramics because of that. So thank you for kind of bringing it all forward. And Tom and Bryan, both of you, I have a few questions that I thought I might just bring up and we could go through. And at the same time, if you feel that you want to take it in another conversational direction, feel free. And towards the end there, we'll answer Q&A from the audience, but also if something populates the chat, folks, we might just pull that in. It might feel like a good way to continue the conversation. So feel free to add into the chat. So a starting point that I think could be fun to look into from what you both presented was talking about your relationships between more ancient technology and emergent technologies, and how that relates to ceramics, like how you've brought those together.
I'm happy to start, or Bryan could start. Yeah, the relationship is so interesting. I mean, it was wonderful seeing your work, Bryan, including some older projects, obviously I was less familiar with. So it was interesting to me, like when I got into this, I had to learn how, I knew the clay part just fine, but learning like how to build these machines, I had nothing that prepared me for that. And that was really hard and a long road and a much deeper rabbit hole than I would have thought it would have been. And it was so funny to watch your presentation, realize like, oh my God, he had to learn everything about clay, which which you kind of take for granted. And so I guess that's a way of trying to answer the question in terms of saying that it's really interesting to to try and build something that's outside of your comfort zone and have to like learn new skills. And to a certain extent, I feel like I could almost feel my brain reorganizing itself as I got really into, making this printer over the years. Because it was just like, you have to look at different things. You have to be sensitive to different things. There's so much more complexity. You start talking to engineers and needing to learn a little bit about what they're doing. And I think, it was really invigorating and really exciting, but it's also, it's such, there's so much there and so many little directions you could take things in. So I'm not sure if that answers the question at all, but I just wanted to, talk about that idea of like having something that you're fairly confident in that allows you to leverage that and leap into something that you're much less comfortable in.
I mean, I think I saw that quite a bit with both of your presentations in terms of just what you got curious about, like what pulled you along, whether that was wanting to learn about throwing for Bryan more recently, or whether that was, diving into how could you animate this. I think that curiosity was there.
Yeah, I mean, I think that Tom put it really well in kind of pointing out the fact that that whether it is this ancient technology that that there's just been so much more time to accumulate knowledge as a civilization around, whether it's that or an emergent technology where maybe you have the opportunity as an artist to contribute something new that's never been done before. Not that that doesn't exist in ceramics, miraculously, after thousands of years, people still do things that are new. But where there are really obvious processes that you could maybe try something that hasn't been done before. Whether it's, either one of those, having this, clearly Tom having the understanding of clay, and I guess the process of kind of meticulously testing, and especially with, being an expert in glaze chemistry, like meticulously testing and getting to a point where you can have sort of like a what do I want to say, an intuitive sense about how things are going to work before you've tested it, because you've done so many experiments before, that prepared Tom, I think, to dive deeper into technology faster than maybe he would have been able to, having not been armed with that. And I like to think that similarly, I was able to jump ahead further into ceramics because I was able to translate my knowledge of kind of the foresight required when you're planning a project digitally or when you're writing code. And I was able to translate a lot of that understanding into this ancient technology. And that was really exciting for me.
Yeah, I think that excitement is really what seems to come forward. I know just with my students, those who are just learning about glazing, there's a real hunger there to know more. And it's quite complicated. It's chemistry and it takes a lot of learning. And yet they're really keen to jump in and learn more and do more. And so there's something about that that relationship, that we're always tool making and problem solving as humans, that just seems to pull us through technologies that are all the way to this current moment, new technologies. Do you notice some of that in your classroom as well?
I'll jump in if that's all right. Yeah, absolutely. I've had the really good fortune to teach a range of different types of students, ranging from obviously students in ceramics and art, but also a lot of designers and a lot of engineers as well. And so what's wonderful is that sometimes you have these different types of students in the same classroom doing the same activity. And this kind of range that we illustrated, like I might have a student who has some of Bryan's capability to work with machines and tooling and stuff, and another student who's just absolutely phenomenal hand builder in clay, but has no prior experience with any digital fabrication tools. And it's really nice to put those people together and see the learning just kind of, happen in collaboration.
Yeah, absolutely.
I had a similar experience in, I guess, a ceramic student took one of my classes, which was just in 3D modeling and 3D printing, and really found it helpful in her studio practice, not for 3D printing, but really just for planning out ideas. And I remember she specifically said at the time, she was an international student, so living in Calgary, but from Los Angeles. And so she would on holidays commute, and she was really excited about the fact that she could work on pottery in an airplane thanks to 3D modeling, and that had never really thought about that before beyond sketching on paper. But thanks to that student, Heather, she's it kind of caught on that this could be a useful thing for ceramic students. So I ended up with a class one semester that was almost half ceramic students and half media arts students studying video production, animation, creative coding. And what was really great is kind of what we were just talking about, that those students could leverage those experiences they already had, especially in collaborative projects. And it became this really high impact, high energy learning community because of the things that people could share. And what ended up happening is one of the media arts students, kind of like I did, really got interested in clay and the properties of clay and how it is, it's harder to control than pixels, and he was excited by that. And then he ended up focusing on that for his capstone project, his undergrad capstone project. And then he was invited to an international workshop led by Jonathan Keep, who is kind of a pioneer in open source 3D printers, clay 3D printers. And then he ended up getting another degree in architecture because of his interest in working with clay as a building material, as a design material. And now he's finishing a master's degree, and his focus is in clay and 3D printing and Adobe structures. And it's really cool to just see that a class could have that kind of impact on someone.
Yeah. I'm curious, just as I'm listening to you, and also in both of your presentations, there is a sense of how you were kind of letting one thing lead to another, but also you were being responsive. And Bryan, you brought up the call and response reaction with one of the printers. This different way to create. And I'm thinking about improvisation and how we've brought that into our conversation, the three of us, when we've talked in the past, and wondering how that might be kind of the metaphor for learning new tools or understanding logic for those tools, and just thinking about what possibilities could come from the improvising and the call and response, sort of creating new experiences rather than new objects. That sense of what you were making was the experience of animating that cube, Tom, not necessarily that you wanted all those cubes. So I don't know if both of you could take turns speaking to that a little bit.
Yeah, sure. I think about it a little bit like the relationship we all have with glazing, that there's this idea always in your mind of like what this glaze is going to look like, right? And then I don't know what percentage of the time it works out exactly like that, but it's not 100%. Might not be like 50%. And so if I'm teaching a glaze class, I always kind of encourage people not to judge the thing when it comes out of the kiln, because that's that rough moment where you had an idea in mind and then it's not that you got. But oftentimes I've noticed so many times with students that like 4 or 5 days later, they're like, you know what, I actually have, now I really like this. Now that I'm over the fact that it didn't do what I wanted it to do, I like it for its own reasons. And so that's my relationship to this kind of improvisation and call and response, is that just mediating like the disappointment in the translation. Anytime something moves from an analog to a digital realm and back, there's noise and there's distortion and there's unexpected things that happen. And it just reminds me so much of like opening up that glaze kiln and being like, oh no, like that is not what I had in mind. But you work with it, right? Because, for many reasons. And sometimes when you can embrace that, it just brings your work into a more open space and allows for you to be observant and responsive to things that were beyond your control, and just to look at things a little bit differently. So I do feel like even though this is a highly programmatic way of working, that there's definitely that space. And I think that's what compels me to make the things in clay, and not just sit there on my digital animation and be done with it, but to want to materialize it, knowing that it's going to fail in some ways, and that some of those ways might actually be really interesting and lead to the next thing that I'm wanting to pursue.
Yeah, those the failure being actually information you use to take the next step. Yeah.
Yeah, I mean, that's been a common thread for as far back as I can remember, all the way back to Stinky Stinkerson. This common thread of, I guess I start with the question of, I wonder what this would look like, or I wonder if I can do this, or maybe I wonder if I can do this complicated thing with the dumb tools that I have available. And through that process of trying it, I stumble upon things that I wouldn't have come up with had I used the traditional tool or had that expensive tool, or maybe hired that person to 3D print that thing for me. It was through the failures and the testing that I made discoveries that took me further down some exploration. So there's that, but then also, and this came up actually when we were, Jen, Tom, and I were having some conversations just preparing for this panel, and Tom compared it to the I believe you said that similar to the experience of clay, of glaze chemistry, and that you maybe when you're learning it seems very programmatic and very rigid, and if you aren't very meticulous and record everything and be very consistent and careful not to contaminate, and you could do a better job of explaining this, but eventually you start to have some more intuition. You can kind of see in your mind's eye what that glaze will look like before you've even started to mix, to formulate it. And it's really similar to me with digital technology. And I know that when students take my first 3D modeling class, and on one of the first days, I like to model something for them. So they kind of are like, it's like ask the audience, and they call out suggestions and I add on to the model. And I want to show them that it can be really improvisational. Same thing with the coding class. I love live coding in front of students because I can model for them the idea that this can be an improvisational process like sketching on paper. And it can be as free and open. And, Tom's idea of the test tile, it doesn't have to be this precious thing that you have to worry won't go wrong if you can feel loose. But in order to have that feeling, you have to do it a bunch of times. And it's very similar. I had that experience most recently learning to wheel throw. I was terrible at it, and I was terrible at it again and again and again, day after day. While undergraduate students were surpassing me and dunking on me, I'm still terrible at it. But then one day it clicked and things started working. And I just really feel like there is possibility. And then there's also this idea of the improvisation happening really intentionally, so like the Oz Bertug, the Carnegie Mellon master's architecture student I showed earlier, set up a system specifically so that you could improvise in taking turns with a robot. Or there's actually something that I presented 2 years ago at NCECA, is a process where rather than creating a 3D model and having your printer print it in one shot, I create one line of code at a time, have my robot print it, and wait for the next instruction. And in real time, I can build. And the same way I was taking suggestions from the audience at NCECA of what the robot should do next. So we improvised on a robot. And so, I think like literally you can do this, but also if you think about it, it's not that different than learning any technology. At first, it's programmatic and rigid, and eventually becomes something that you can, that maybe improvisation and is possible.
Yeah, it's sort of developing a freedom through getting more familiar with something, getting to know something a little bit better, which is the freedom we all can experience in studios, no matter what material we're using. But in ceramics, I certainly feel like I've had those moments over and over again. I'm noticing the time, so I just want to do a little check-in and say maybe we can do a wrap-up question. We've had a few questions in the audience, but I would like to just say for there's a few more questions I want to ask, but I think we can maybe do one. So it's a little bit of wrapping up, and it maybe covers all at once. We're thinking about like, where does the art happen in all of this? And we've spoken to it a little bit, but maybe bringing that in, and also thinking about how that is affecting your upcoming projects. And even the final kind of buzzy topic we thought about, which was what about AI in all of this? So kind of a wide brush there, but thinking about where art happens in the process and your upcoming projects, and where does AI fit into all this?
We can keep with this pattern, and I'll jump in on these questions. As far as where does the art happen, that's so hard. And my instinct is to say it's always happening, right? That it's hard to make that distinction. And I see also there's a question about, is the technology the subject or the technique, which is a wonderful question. And I would hope that it's the, it could be either. I feel like in my own experience, speaking for myself, I had to go through a couple year period where I was just so focused on the technology, or it wouldn't have worked, like I just had to totally commit to that. And I feel really good that I feel like I'm on the other side of that, and the art comes back into it in a different way, a way I'm more familiar with as an artist. But it also helps me appreciate engineering and engineering design as an art. Help me understand the creativity in that as well. As far as AI, I wanted to mention something about that. I follow all those developments, and I'm not interested in AI as an author, like letting the AI really drive the research, but I'm really interested personally in AI as an assistant. There's a really well publicized protein folding AI thing where it ran through all these combinations of protein folding to make these incredible discoveries, just doing work that would have taken forever. I want to apply that to like glaze formulation, like have an AI that just makes all the terrible glazes and runs through all the wacky combinations, and then somehow, does like what you would if you had 100 assistants just making test tiles all day, have the AI do that somehow, or be better at saying like, if we can no longer get this ceramic material, could an AI like produce a recipe of other materials that would equal that? That's my interest. A little mundane, but that's my interest in AI. And then the last thing I'll say is things for the coming year. I really want to embrace what I was trying to say about like the mentality of making test tiles or just viewing that as important. And I've really enjoyed teaching glazes, and I want to be more consistent with like making test tiles as almost like a journaling process. Like literally I'll wake up and make some test tile and begin my day, that it's like folded in, like trying to eat well, trying to get some sleep, and trying to exercise. I also want to try and make a test tile every day, whether it's good or bad, not judge it, but just have this library that's going. And so for me, it's a little bit about consistency. Some of these projects that I described, they take a really long time. My time is fractured enough as it is, so you can really feel like you're not seeing the kind of call and response improvisation that we were talking about. And so I want to have a part of my art practice or work that is like super consistent, even if it's small and fairly insignificant. I'm just making a slightly different version of that test tile that I made yesterday. But so for me, it's about consistency and trying to find a daily practice that makes sense amongst all these longer scale projects.
Thanks, Tom. Bryan?
Yeah, I think I'll start with the AI art piece. I think the thing to me that is you could look at it with kind of dread, but you also could look at it as very exciting in some ways. And I think it's especially relevant for this audience too, in thinking around, what did photography do to painting? Did it replace it and make it obsolete and destroy it, or did it elevate it and maybe force artists to do something a little different if they wanted to do something that photography couldn't? I think it's similar to that. I also think it's really interesting that since the Industrial Revolution, we've really thought so much about automation being mechanical tasks. And one of the most kind of buzzy topics in AI is this AI art generation, right? You can generate a painting or a character design, etc., by feeding a prompt into an image generator. And I think what's really interesting about that is that, or you could think about ChatGPT, which can write poetry and can even write code that, in some cases as well as a human. So automating these non-mechanical tasks, and like, so what does it look like when we take something that, is like, will it elevate these tasks like photography did to painting? Will coding become an art form in the way that painting has, or sculpture? Will, that's an exciting idea for me. I think it's just a paradigm shift. And I think that, if we can automate things, it's easy to think about automating jobs that people don't want to do because they're mechanical jobs. But what happens if we automate jobs that are those really sought after jobs? And what happens when there are no jobs anymore? And how do we survive? And yeah, like that can be, you could think about sort of a a doomsday scenario there, but I think it's more productive and in some ways more realistic to think about, maybe none of us have to work one day. I could go on and on about this, but yeah, I think that that there's some interesting things happening. In my own practice, I'm learning it and I'm learning how to use it. I have no idea what to do with it yet. It's just it hasn't inspired that but it might just be I haven't dove deep enough yet. It might be that I haven't found that part of the process that, oh, I wonder if this has ever been done or whatever. So the other thing I wanted to touch on is just what is coming for me. And so I last summer did as kind of leading up to my sabbatical, I did a residency at Medalta, which is a historic clay center in southern Alberta. And what I focused on there mainly, having access to Plainsman clay nearby, was learning more about clay chemistry. Specifically, I had an idea for 3D printing kind of delicate structures, and so I needed to find a clay that would be very structural, that would not shrink very much, and kind of do all these specific things. And I needed another clay body that could act like glue and do a really good job of assembling pieces. And this was all basically leading up to an idea I have for a larger project where I'll be building 3D printing flat structures and then assembling them, basically like hand building. Like slab building, except the slabs are these really delicate lattices. This is a little example of something that I made after kind of finding some successful clay bodies. And so each of the sides of this tetrahedron are 3D printed, but then I'm assembling them by hand. And just as a little test or like to satisfy a curiosity, I trapped a little slip cast tetrahedron inside. But yeah, I want to I'm thinking about scaling this up. I'm thinking about creating modules. And I guess I'm like just discovering some of the things that I think have been exciting Tom for many years, like modularity and yeah, thinking about scale. And I also love small objects, but part of that is I haven't forced myself to go big yet. So yeah, that's what I'm thinking about right now.
Amazing. Thank you both. I'm wondering if there's one last thought or burning question from the audience before we stop for the afternoon. Feel free to raise your hand or put it in the chat.
One thing that I'd love to respond to that idea. It's a great question of, is technology the subject or a technique? All I will say is that, coming through, like really being trained in a new media environment, that's something that's talked about a lot. And I think it's really just the nature of anytime you create an artwork, you're really kind of amplifying a moment or a scenario, but you're also limiting that moment or scenario, right? So like a painting, it freezes or a photograph freezes a specific moment in time and is highlighting or amplifying a moment, but then the photograph ends. It falls off the page. There's a frame restricting it. So it's a limitation. And I think that limitation is really apparent when you work, especially in digital media. And so sometimes it's hard not to explore that limitation itself. And this isn't different. It's not specific to digital media. I think when you listen to, a jazz song and the singer their voice is likely intentionally cracking because that's a specific timbre. It's a specific aesthetic quality that is actually sought after. It maybe once was considered a mistake, but is intentional. Or you might leave the spiral at the end of a pot that you threw on a wheel to show that it was wheel thrown, right? That makes it about the technology. It's hard to avoid it when the material and everything you're doing is kind of celebrating that technology and exploring the limitations. That's at least what happens for me, and why so much of my work ends up circling back to being about what it's made of.
Great, thank you. There's a question that came through, and I think Tom's answered a little bit, but just if an experienced clay hobbyist wants to join a 3D printer exploration, where do you start? You know, in classes or with a book or commercial printer?
Yeah, the reason I said a class is I think a class or workshop particularly is such a great way to, like, you know, see how you respond to something. When I used to teach mold making, I used to joke that part of the role a mold making course fulfills is to let people know why they don't want to make molds. And I say that I love making molds, but certainly there's, you know, we all have to try processes, and sometimes we can recognize why it's a great process and also recognize why we're not the right person to do that process. I feel that way with wheel throwing, for example. So I think the great thing about a workshop is, like, you can find, do I love this, or do I just appreciate this, without the commitment of, like, you know, these an expensive printer, something like that. I don't know of a great book. I do know a couple efforts have been made to write a book about clay 3D printing. It's been a fast moving target, so it's hard to write a book about it, but I think there needs to be a great book, you know, alongside books about glazing and things like that have long since been in our sort of collective libraries.
Great, thank you both. I'm just gonna bring us all into the same view here. There we go. Thank you both. This was amazing. I super appreciate all of your insights and inputs, and just every way in which you've kind of opened this topic to a wider audience, so that we could keep exploring ourselves. I look forward to seeing more of your work in the future from both of you. And thank you all to all the audience for sticking with us and really enjoying this process. We'll see you again soon.
Thanks so much.
Very much.
Thanks, everyone.
Have a good evening, everyone.